Today we are going to discuss about this LDO, such that what is this LDO? LDO is a low drop output voltage or a converter, we can say. Here then main things are coming key where we have to use the LDO, or what is the properties of the LDO, and where we have to use the LDO and buck converters. But in this section we are going to discuss about the LDO only. Okay, then basically we are seeing here ki in LDO the regulation is happened with the in linear region only. Here no switching is happened as per the buck regulator. Then here always output voltage is lower than the input voltage. Where we have to use basically in LDO we are not getting any ripples, such that we have to use where we need proper clean output, and the difference between the input and output voltage is less, and we need that like efficiency is not a matter, and we need this out, less output current, and where EMI EMC is like having a problem, then I can say ki at the case of the ADC and all we should have to use this LDO. What is dropout? Basically one function is coming in the dropout. Then dropout refers such that what we are supplying at the input and what we are getting, and after that what is okay. Dropout voltage basically it refers such that what is the dropout, it happens inside the LDO. Like if we are applying whatever the voltage we are applying, like a 3.3, and after that we are getting the 2.5, then in this case whatever the difference between the input and output, that is the dropout. Then here we are taking an example. Consider an LDO like this TPS 799. Then here in this case at least it is like a sourcing, it is 200 milliampere. In this case we should have to know what is the minimum we have to apply. Then if we need like output is the 3.3, and in the data sheet it was mentioned that this dropout is the 0.175, then minimum voltage we have to apply it from the input side. Here we can see with the formula, dropout is equal to V in minus V out. Then in this case what happened ki always whatever the dropout it is there, then we should have to add with the output, and after that that is the minimum requirement to apply as a input voltage. What determines the dropout at? Here like if we are coming in this architecture of this LDO, then first of all always we are preferring this low dropout for the LDO. Otherwise what happens, there will be multiple problems, is that heat dissipations it will be increases, and then at that case we should have to take in care for the layout point of view and all, and maybe it will reflect to output also, and it will create unnecessary issue with other components and ICs. Then there are the two types of LDOs like PMOS and NMOS. Here in the PMOS, basically how we have to know key like this feedback circuitry is connected in this positive section of the error amplifier, and the vref we are providing in this negative section. At that case what happened he always like whatever the PMOS or NMOS, then whatever the input voltage we are providing, then at that case it is approaching to V out. Okay, but what happened due to this RDS on and all, there are some dropout which happens. Due to that what happened ki we are getting some less output in the output. Then in this case we should have to take in care for this dropout section, such that we have to regulate properly. Otherwise what happen ki we will get the if you are coming in this section, like what is this dropout, then RDS, okay, then output current and multiplying with this RDS, that is the complete dropout we are getting. Then we have to minimize this section, otherwise heat dissipation and all it will be increases. NMOS LDO, in the case of the NMOS LDO, as we see this feedback circuitry is connected with this negative terminal of this error amplifier, and after that this error amplifier is controlling the gate voltage of this MOSFET. In this case what happened, he always, when we are increasing this VGS, at that case what happened, ki RDS will be decreases such that we can reduce this total dissipation. In this case it means like a dropout. It means what happened, key in a particular range, while we are increasing the VGS at a particular time, RDS cannot be decreased. Then that is the uh, point, key that is the minimum dropout we will get at that moment. Okay, there are some methods due to that we can decrease this dropout and all. And in this case, one is this biasing of the LDO. With the case of the biasing, what we are doing, when we are applying the external voltage in the error amplifier, it is not happening in all the LDO, but in some LDO having this functionality. Like at that case, what happened? Ki always we are getting this low dropout, and due to that what happened, ki we will getting this low dissipation, and we are getting this proper output, and like heat dissipation it will be less, and it will not affect to other ICs also. Here if we are getting in this summary, then what happened, ki where we are using this PMOS, where we are using the NMOS, then what happened in this PMOS, when we are increasing the output at that time, like our dropout is decreasing. Okay, and in the case of the NMOS, when I am like less output is required, then dropout is decreasing. But this is this biasing case. Always we are know कि when output current we are increasing, then dropout is always decreasing. The same with the temperature, junction temperature is increasing, and at that moment dropout is also increasing. Okay, thank you.